Okay guys, we're beginning today's lesson and we're going to be graphing parabolas in standard form, page 9 in the unit 4a packet. So standard form is y equals ax squared plus bx plus c. If you guys have been doing your work, you've seen this for the past few days. You've also seen how we found the vertex using the formula negative to find x first, negative b over 2 times a. Then to find the y, you were supposed to take that number for x, plug it in for the x's into the formula, and solve for y. So here's the steps to graph a quadratic. Please pause this and take notes. And I'm going to go right into doing the examples. I'll be talking about the steps as I go through them. So for the first one, I would say call this, what's a, b, and c? I would call this 1x squared plus 0x plus 0. Only the x squared is shown. That has an invisible 1. So to find the vertex, we're going to have to do negative b over 2 times a. So that'll be 0 over 2 times 1. So that's 0. Anytime you have 0 in the numerator, it's going to be a 0. So that's the x-coordinate of the vertex. Now, to find the y-coordinate, we have to take the 0 and plug it back into the x's into the original formula, which would be right here. So we would have y equals 0 squared, which is 0. So I now have my vertex 0, 0. I'm going to go over to my graph and plot that point now. Now, where this step says draw the axis of symmetry, I don't need to worry about that because it's in the dead center. The axis of symmetry, the middle line, vertical line, is just going to serve as the y-axis. So now I need to go to my table of values. So I need to look at my x-coordinate of my vertex. And after 0, you pick 3 numbers that come after 0 on a number line. 1, 2, 3. So then from there, what you need to do is figure out what its y-coordinates are. So just like you did back here, you're going to do that procedure 3 times with 1, 2, and 3 going in for the x's. So this will be 1 squared is 1. Again, I'm using this formula up here. 2 squared is 4. And 3 squared is 9. So I have my other points. I'm now going to plot those. So 1, 1. We had 2, 4. And we had 3, 9. Now that forms the one side of the parabola. We need points on the other side of the axis. So this will be 1 over from the axis, 2 over from the axis, and 3 over the axis. It's like when we take in elementary school and take a paper and fold it over each other. All right, it's mirrored. It's called symmetry. And then lastly, connect the dots and draw your parabola. Make sure to put arrows going to the edge of the graph because parabolas do go on forever. Okay, example 2. So if I write this guy out, I would say a is negative 1 because it has the x squared with it. B is 0 here. That minus 5 is actually what we call a constant. That's the c. A constant is a number that does not have a variable with it. So let's go to our vertex. We have to do negative b over 2 times a. So that would be 0 over 2 times negative 1. Again, anytime you have a 0 as a numerator, anytime the b is a 0, the x-coordinate is going to be 0. Then we're going to take that 0 and plug it back in for x, back in the original equation. And then you can use a calculator, or you should be using an order of operations. So squared, subtract, and your y is negative 5. So there's your vertex. I'm going to plot that now. 0, negative 5. The axis of symmetry, again, I don't need to draw it because the y-axis can serve as the AOS. So what do I do next? I need to go back and get the table of values. Okay, so when I do this, just like in the homework, you're going to have to use a table of values. You can't use rough sketches here. I need to see points. I need to see the table properly filled out to receive your full credit on your homework. Okay, so what x value should I choose? Again, you look here, the x coordinate of the vertex. That number is 0. Choose 3 numbers after 0. So 1, 2, 3. And then you're going to use the formula again. So I'll take 1, plug it in, carry over the negative 1. That's negative 6. I'm just going to fly through these quickly. Negative 9, and then negative 3 squared minus 5, negative 14. Now the negative 14, we don't have to worry about that point. It's too far off the graph. Our graphs only go up to 10, or I'll even try to squeeze in 11 if the graph's all right. So let's plot those points. 1, negative 6. And we have 2, negative 9. So that forms the right side of the parabola. So now I'm going to get points on the other side of the axis. 1 and 1, 2. And then you're done. Example 3. A is 1, B is negative 2, C is negative 1. So to the vertex, negative B, B is a negative, so that's a double negative, which will change to a positive. Be careful with your signs. And then 2 times A, so we'll multiply and divide. So our x-coordinate of our vertex is 1. Now, take the 1 and plug it in for the x's in the equation here and here. So that'll be 1 squared minus 2 times 1 minus 1. So multiply, and then add those up. And I'll have the y-coordinate, negative 2. Again, be careful with your order of operations when you're finding your y values. Make sure you're doing exponent first, then multiply, and then add. Okay, so my vertex is 1, negative 2. This guy I will have to draw an axis of symmetry. Remember this axis of symmetry. It is an invisible vertical line, and it's just a line that's going to guide you for the points after you do your table of values. And the axis of symmetry is always going to cut through the vertex. Now I need to go back to my table of values. Now, what x's do I choose? Don't choose 1, 2, 3 this time. My vertex's x-coordinate is 1. So I actually need to choose, after 1 comes 2, 3, 4. So now I'll plug them into the formula to find their y values. That'll be negative 1. That'll be 2. And that'll be 7. So I plot those points, 2, negative 1. 3, 2. And 4, 7. So that'll form my right side of my parabola. Make sure to draw to the edge with the arrow. And then get mirrored points on the other side of the axis of symmetry, which is the dotted line. And then your parabola is done. Next, just getting more practice in. So let's find the vertex. So negative, and b is a negative, so that'll be a double negative 8, which changes to 8. And then 2 times a, which multiplies to negative 4. And then divide to have negative 2. X coordinate of the vertex, negative 2. Now to find the y, take the negative 2 and plug it in for the x's, here and here. Now, since I'm plugging in a negative, whenever you're plugging in a negative for x's, especially dealing with an exponent like the x squared, make sure you're carefully using parentheses. When I'm plugging in positive numbers, I don't care too much about the parentheses, but negatives are important. So it'll be negative 2 squared is 4. So exponent, then you can multiply, and then you can add 8 and 1, 9. So the y coordinate is 9. So I got my vertex. Now I'm going to graph that to negative 2, 9. Now I'm going to go to my axis of symmetry and draw my invisible vertical line. Remember, it's got to go through the vertex. Now I need my table of values to get my other points, to really form, you know, how the parabola is going to look. All right, so this guy, what x values do you choose? You should choose, after negative 2 comes negative 1, 0, 1. Or you could also choose the other side of negative 2, negative 3, negative 4, negative 5. All right, so let me go with the negative 1 here. That'll be 1, negative 2 plus. I'm just trying to go quick here. That'll be 7. When you plug in the zeros, that'll be 0, 0, 1. When you plug the 1s in, that'll be negative 9. Just using a little quick mental math here to not take up time in the video. All right, negative 1, 7, I'm plotting now. All right, let me try that again. Negative 1, 7, 0, 1, and 1, negative 9. So that'll form the right side of the parabola, and then form the other side with the points on the other side of the axis of symmetry. Let's say here, and there. 1 away, 2 away, 3 away. And then you have a very stretched out parabola. Okay, I want you to pause right now. You're going to try this one out on your own. Okay, so how I would call this guy is, I would say the a is negative 4 because it has x squared. The b is 0, and the minus 1 is a constant, so that's the c. So to get the vertex, negative b over 2 times a. 0 is on top, so it's going to be 0 for the vertex. And then I'm going to get the y. I'm going to plug in the 0 in for the x in the formula. And that'll be 0 minus 1 is negative 1. Taking shortcuts there when I'm doing my steps. I mean, you guys should be good at that point. All right, so now I'm plotting 0, -1. And my x values, I got x here is 0. So after 0 would be 1, 2, 3. Now I'm going to use my formula again to get my other y values. That would be -5. The second one, when I plug 2 in, would be 4, -16 minus 1, -17. And then 3 plugging in, 9, -36 minus 1, -37. All right, I have a very stretched out graph. Actually, these points are not even going to fit on the graph. It's going to appear super, super thin. All right, so I'm going to plot 1, -5. Also, notice I did not put an axis of symmetry. It's because it's in the middle, and that would be the y-axis anyway. So now that'll form the right side of my very narrow parabola, and then get a point on the other side of the axis and draw also very stretched out or narrow parabola. Okay, try this one on your own now. So a would be -1, so I'm getting the x coordinate. So -b over 2 times a. My x coordinate is -3. Now I'm going to plug that in back into the formula for the x's and then find out what the y is. So squared, and then I can multiply in the same step. That'll be -9, -6. So I'm going to plot that vertex now, -3, -6. And now I'm going to draw my axis of symmetry, my invisible middle line. I want to remind you guys, if I'm going too fast for you, please feel free to watch again. Always watch things more than once if you're confused. Okay, now the x values. So I'm looking here, this first one in the vertex -3. So after -3 would be -2, -1, and 0. So I'm going to use the formula now. So -2 squared would be 4, multiply minus 12 plus 3 be -5. Plugging -1 in would be 1 minus 6 plus 3. That would be -2. And then plugging 0 in would be 0 plus 0 plus 3 is 3. So I got my other points. -2, -5. -1, -2. And 0, 3. So I'm going to have that right side of the parabola and get mirrored points. This first point's always 1 across from it. Second is sec2 across from the axis. And the third is always 3 across from the axis. So it's just a little bit of counting. And then there's your parabola. And that's it. My lesson is done.